So we were talking about variables. We're going to watch a short video that explains that in a little more depth.
When scientists set up an experiment, the way that they test their hypothesis is by having a variable. And so let's just start off with an example hypothesis. Let's say that I think that my houseplant will grow more if I give it a half cup of energy drink every day. In my experiment, I'll have one houseplant where nothing changes. So both of these houseplants will be exactly the same temperature, and they'll get the same amount of sunlight, but there'll be one difference, and that is called a variable. And so this plant over here would be the variable group, and this plant over here will be the control group. And the one thing that we're going to change in this experiment is I'm going to see if giving my plant a half a cup of energy drink every day will make it grow more. So here's my energy drink can, and there's some energy drink. The energy drink that we are giving to this plant, we would call the independent variable, because that's the variable that we're controlling. Independent. The independent variable. And the dependent variable in this case is the plant's growth. So let's just say growth. I'll switch colors here. All right, so the dependent variable is how much the plant is growing. Growth. All right, so there you have it. We have a control group where nothing has changed, a variable group where we're only changing one thing, the energy drink. The energy drink itself is called the independent variable because the independent variable is something that the scientist is controlling. And the dependent variable, how much the plant grows, is called the dependent variable because it depends on the independent variable or the energy drink.
Okay, so the independent variable is the thing we change, and the dependent variable is the outcome because of that change. Why do we need variables? Here's another short video that helps us understand that.
Will white chocolate melt faster than dark chocolate? Experiments are used to answer questions like this. Most experiments are set up to see if a change in one factor causes a change in another factor. These factors that can be changed are called variables. There are three main types of variable: independent, dependent, and controlled. The independent variable is the factor in an experiment that the experimenter changes. This variable is not influenced by any other factors in the experiment, but it causes change in other variables. In other words, the independent variable is the cause of change in an experiment. Variables that are changed by the independent variable are called dependent variables. A good experiment only has one independent variable so that the experimenter can be sure that changes to the dependent variable are caused by the independent variable. Which soap is the best at killing germs? To answer this question, think like a scientist.
Once you've figured out what your variables are and what you're testing, and you've got your tools and you've set everything up, the last step is to conduct the experiment and record your data. Before you begin, you need to decide what information you're going to gather. You may want to sketch what you're seeing as it occurs. You may want to create a data table where you keep track of temperatures or the amount of time going by or how many times something occurs. You may want to draw pictures as line graphs or bar graphs. You may even want to use video or a picture to capture what has happened. Lastly, you're going to summarize and share your results. We're going to use a CER to do that, and that's a whole nother lesson in and of itself. But a CER is three parts. There's your claim. What do you believe happened after conducting the investigation? The E for evidence. What evidence do you have from your data and your observations that support what you believe? And the reasoning is the scientific principle that ties your evidence to your claim and supports your conclusion.